Hello, I'm Nikolas Krisma Hadi Fernandez, and through this video, I will explain about my thermodynamic experiment for my senior mechanical laboratory course. So, for this thermodynamic experiment, we'll do this with this schematic. So, there are several objects here, which are the box, the heater, the pressure gauge, and the thermometer. So, the heater inside the box will heat up the air inside the box, and from the pressure gauge, we will measure the pressure, and the thermometer will measure the temperature of the air. So from this equation, ideal gas equation, PV is equal to mRT. If we keep the volume and the mass of the air, we'll we'll see that if we increase the temperature, then we also increase the pressure. So we'll try to prove that through this experiment. So this is the assembly. So before that, all the objects that have previously mentioned are purchased from the online shops, and it is shipped to my hometown, which because in this pandemic we cannot use we cannot use schools laboratory to do the experiment like this. So for the experiment, the first thing that we need to do is make holes at the box that we have already have. So I made four holes, which are the holes A, B, C, and this is hole D. So for hole D, it is used to as the gate of the cord of the electrical heater, cord of the electrical heater. So this when the electrical heater is inside the box and the cord is outside and through the hole D. Is another picture. And this is the thermocouple that we use as the thermometer, and we will use it as the sensor to measure the temperature inside the box. So we insert the wire here inside the box through the hole B here. So this is another picture of the thermocouple wire that we insert to the box. And this is the pressure gauge that we use. So we'll insert the pressure gauge to the box cover for at the hole A. And this is the assembly. So this is the thermocouple that we use to measure the temperature. This is the heater to heat the air inside the box. This is the box itself, and this is the box cover. So for the holes, we use paraffins to uh, close all the holes as much as possible. Also for holes A, B, C, and D. So this is the experiment. Again, from this schematic, we expect that if we increase the temperature inside the box through with heater, we'll increase the pressure also, and we'll measure the temperature inside, and we'll compare to the pressure gauge to the value that pressure gauge given to us. So this is the experiment. This is the temperature of air temperature inside the box, and this is the pressure. It's still zero here. As we can see that it is increasing, the temperature is increasing, and I will speed up the video from now on. So we can see that the temperature increases up to 101.5, but the pressure is not increasing at all. So there may be several reasons. The first is there may be leaks on the box itself that made the air inside it escape it and not increasing the pressure. So there change in the volume so that the pressure is not changed, and for so maybe there are several leaks on the box that make the air escape from those leaks and change the volume so that the pressure is not changing, and the pressure change may be smaller than pressure gauge resolution. So maybe the pressure have changed, but it is very small change that the pressure gauge resolution is think that it is not changing at all. So maybe the pressure gauge resolution need to have a pressure change of 1 bar, but the pressure change that it is actually around just 1 or 2 Pascal. So I've done another experiment for this with another device, which is in this is a do-it-yourself manometer. So this is a pipe that is connected to the box, and this is the heater. Also, this is paraffin, a ruler, and a water inside the pipe. So the method is just when the pressure inside the box is higher than the pressure outside here, then the water here will be lower while the water here will be higher, and the difference between height of those area we can calculate the pressure from that using P is equal to rho GH, where rho is the density of the water, G is the gravitational constant, and H is the difference of the height of those area. So this is the experiment for this new device, this new pressure device. And we can see that the temperature is increasing while even is just so slow. And I will speed up the video from now on. So as we can see from previous one, the water level does not really change. So again, the reason is there may be leaks on the box itself, so the air is kept and not increasing the pressure, so uh, it make a volume difference, then it does not change the pressure inside the box. And the pressure may actually not change, or the change is again very small compared to the atmospheric pressure. So the pressure change or the pressure inside the box may be just slightly a little bit higher than the pressure outside, the pressure uh, on the environment. So the water level does not really change, that it is still on the on the same level as we can see from the previous video. So that's basically it. The experiment is again fail, and these are the reasons why it may fail. And thank you. That's all for this experiment. And for the experiment, we can see that the pressure may maybe change, but it's very little. It's very small. The change is very small, and we cannot see it through the sensor that we have already used. So from this experiment, we also learned that we need to have a specific sensor to measure the pressure change here, because the pressure change here is very small. So we cannot just use any sensor and expect that it will measure the very small pressure change. And for the course itself, my feedback, I don't have any feedback. The course is already great. The methodology and how we uh, plan the experiment, how we do the step by step, and how we purchase the parts is already good. The method is already good. The experience are also, in my opinion, we have got the experience on how we plan the experiment and how we expect what will we get and what variable that we will uh, compare here. So it's really good, and I don't have any feedback. It's very good, it's challenging, and it's fun. That's all for this video. Thank you.